Hello students, this is Teacher Darrell. In this video, we will be proving theorems on trapezoids and kites. For the first half of our discussion, we will be talking about trapezoid. So, trapezoid has the following properties. It has at least one pair of parallel sides. Next, the median of the trapezoid is parallel to the bases, and it is one half of the sum of the bases. Therefore, median or mid-segment is equal to base sub 1 plus base sub 2 over 2. Using the property of the trapezoid, let us solve the following problem. Use the property of trapezoid in finding the length of mid-segment ON. So the given values are segment JM is equal to 6, segment KL is equal to 4, and what therefore is segment on O. So the solution would be, using the formula, mid-segment is equal to base sub 1 plus base sub 2 over 2. So all we have to do is substitute the values to the equation. Base sub 1 is equal to 4, base sub 2 is equal to 6, so that gives us 4 plus 6 over 2, and that is 10 over 2. So the mid-segment is equal to 5 units. Therefore, there are many theorems on trapezoid, but for this video, we'll be proving two of those theorems. So the first theorem is, if a quadrilateral is an isosceles trapezoid, then its legs are congruent. So, given isosceles trapezoid ABCD, as you can see the figure, prove that segment AD is congruent to segment BC. We will be using a two-column proof for this proving. Proving is all about making connections. So if you're going to make a statement, you must always make sure that you can make a new statement out of that statement. So for our proof, we have the first statement, ABCD is an isosceles trapezoid. Reason, given. Second statement, angle A is congruent to angle B, and that is an isosceles trapezoid has congruent base angles. Third statement, draw line DP perpendicular to segment AB and segment CQ perpendicular to segment AB. Reason, from a given point not on a given line, only one perpendicular line can be drawn. Fourth statement, angle DPA and angle CQB are right angles. Reason, perpendicular lines meet to form right angles. And number 5, angle DPA is congruent to angle CQB, and the reason is all right angles are congruent. Sixth statement, DP is equal to CQ. It is because parallel lines are equidistant, meaning they have equal distance. Seventh statement, segment DP is congruent to segment CQ, and the reason is congruent segments have equal measure. Number 8 statement, triangle DPA is congruent to triangle CQB, and the reason is angle side postulate. And the last statement, segment AD is congruent to segment BC, and that is the CP-CTC, or the corresponding parts of a triangle is congruent. Now let us go to the application of the theorem. Given isosceles trapezoid ABCD, where segment AC is equal to 4x minus 1 and segment BD is equal to 2x plus 5, find the length of the legs of the trapezoid ABCD. First, look at the figure. And now the solution is, since segment BD is congruent to segment AC, AC is equal to BD. Substitute the values. We have 4x minus 1 equal to 2x plus 5. Now let us solve for x. 4x minus 2x is equal to 5 plus 1 by combining like terms using addition and division and subtraction property. Now we have 2x equals 6. To get rid of 2, we divide 2x and 6 by 2. Now we have x equal to 3. For segment AC, we have 4x minus 1. Therefore, 4 times 3 minus 1, and that is segment AC is equal to 11 units. And for segment BD, we have 2x plus 5. So substituting the values, we now have 2 times 6 plus 5, that gives us 11 units. Therefore, the size or the lengths of the legs of trapezoid ABCD are 11 units. For our second theorem, we have, if a quadrilateral is an isosceles, the diagonals are congruent. Take note, length of the diagonal is equal to the square root of AB plus C square, where A and B are the bases and the C is the leg. So we have to prove, given that PQRS is an isosceles trapezoid, prove that segment PR is congruent to segment QS. The proof of that theorem is, first statement, PQRS is an isosceles trapezoid, and that is the given. Next, segment PS is congruent to segment SQ, and the reason is, definition of an isosceles trapezoid, it is taken from the first statement. Next, angle SPQ is congruent to angle RQP. Reason, base angles of an isosceles trapezoid are congruent, so it is still from the statement 1. Fourth statement, segment PQ is congruent to segment PQ, and that is the reflexive property. Fifth statement, triangle RPQ is congruent to triangle SPQ, and that is the side angle side postulate. And you can see the reasons from 2, 3, and 4 statements. Last statement, segment PR is congruent to segment QS, and that is the CPCTC, or again, congruent parts of a congruent triangle are congruent. Take note that you can only use the CPCTC if we already proved that two triangles are congruent. Now let's go to the application of the theorem. In an isosceles trapezoid, PS is equal to 5 cm, QR is equal to 3 cm, PQ is equal to RS, which is 4 cm. Find the length of the diagonals. Solution. Let A be the length of PS equal to 5 cm, and B be the length of QR, which is 3 cm, and C the length of each leg PQ and RS, which is also 4 cm. So let's use the formula. Length of the diagonal is equal to the square root of AB plus C square. Substituting the values, we now have square root of 5 times 3 plus 4 to the power of 2. It is equal to square root of 15 plus 16, and that is square root of 31, and the square root of 31 is equal to 5.5. So the length of the diagonals are 5.5 centimeters. Now we are down to the last half of our discussion. Let's go to the theorems on kites. So, what is a kite? A kite is also a quadrilateral with the following properties. two distinct pairs of adjacent sides are congruent, diagonals are perpendicular, one pair of opposite angles are congruent, and the diagonals bisect each other. So those are the properties of a kite. So if you find or prove a quadrilateral with those following properties, therefore that quadrilateral is a kite. Like our previous discussion on trapezoid, on kites we will be proving also two theorems. So the first theorem is, if a quadrilateral is a kite, its diagonals are perpendicular. So given kite ABCD, prove that BD bisects AC. For the proof, we have the first statement, ABCD is a kite, and the reason given. So for that statement, we can say that segment AB is congruent to segment BC, segment AD is congruent to segment CD, and the reason would be a kite has two distinct sets of congruent adjacent sides, so that those are taken from the properties of a kite. The third statement, segment BD is congruent to segment BD, and segment BE is congruent to segment BE, and that is the reflexive property. Next statement, triangle BAD is congruent to triangle BCD, and that is the SSS postulate. That is taken from the first three statements. Next, statement 5, angle ABD is congruent to angle BCD, and that is the CP-CTC. Because we already proven that BAD is congruent to BCD, we can say that those corresponding parts of the two triangles are also congruent. Next, triangle BAE is congruent to triangle BCE, and that is the side angle side postulate. Seventh statement, AE is congruent to CE. Again, that is the CP-CTC, because AE and CE are parts of triangle BAE and triangle BCE. Next, segment BD bisects segment AC, and the reason would be a segment bisector forms two congruent segments. Let's go to the application of the theorem. In a kite ABCD, AB is equal to x plus 2, BC is equal to 2x plus 1. The perimeter of the kite is 48 centimeters. Find x and also the length of each sides. First, look at the figure and examine what are the sides given. Solution. Adjacent sides in a kite are equal, so we can say that AB is equal to AD and BC is equal to CD. Let us recall that the perimeter of a quadrilateral is equal to the sum of all sides. So, since the perimeter is 48, we substitute it to the equation. We now have 48 equal to x plus 2 plus 2x plus 1 plus x plus 2 plus 2x plus 1. Simplifying, we now have 48 equal to 6x plus 6. Next, to get the value of x, we have 6x equal to 48 minus 6 using the subtraction property. Next, 6x is equal to 42, and to get rid of 6, we now have 6x divided by 6 equal to 42 divided by 6. That gives us x equal to 7. Now we have the value of x, we substitute it to the values of the segments. So AB is equal to AD, and that is equal to x plus 2. So x is 7 plus 2, that is 9 centimeters. Next, BC is equal to CD, and their measure is 2x plus 1. Again, the value of x is 7, that gives us 2 times 7 plus 1. So BC equal to CD is equal to 15 centimeters. Second theorem on kites. If a quadrilateral is a kite, it has one pair of opposite angles that are congruent. So, we have to prove this theorem through given kite ABCD. Prove that angle A is congruent to angle C and that angle B is not congruent to angle D because it is said that it has only one pair of opposite angles congruent. For the proof of that theorem, we have the first statement. ABCD is a kite. Reason given. Second statement. Draw line BD or segment BD. And the reason would be 2 points determine exactly one line. Next, segment AB is congruent to segment BC and segment AD is congruent to segment CD. Reason, a kite has two distinct sets of congruent adjacent sides. Next, segment BD is congruent to segment BD, and that is reflexive property. Now, we have triangle BAD is congruent to triangle BCD by the SSS postulate or the side-side-side postulate. Since we have proven that triangle BAD is congruent to triangle BCD, we can say that angle A is congruent to angle C, and that is the CPCTC. Now, assume that angle B is congruent to angle D. The reason would be assumption leading to a contradiction. Number 8 statement. ABCD is a parallelogram. Reason, if a quadrilateral has two sets of opposite congruent angles, then it is a parallelogram. With that reason, we can say that angle B is not congruent to angle D, and the reason is contradiction. So that proves our theorem. Now let us go to the application of the theorem. Calculate the measure of the unmarked angles of the kite KITE. So, look at the figure. K is equal to 100 degrees. Angle E has no measure. Angle T has also no measure. And angle I is 20 degrees. So, we are asked to find the measures of angle E and angle T. So, the solution, angle K is congruent to angle 3. And that is from the property for the theorem proven a while ago. So, let us remember that the sum of the interior angles of a trapezoid is 360 degrees. That is, 360 is equal to angle K plus angle I plus angle 3 plus angle 4. First, let us solve for angle 3. We have said that angle K is congruent to angle 3. So, angle 3 is also 100 degrees. Now substitute the values. 360 is equal to 100 degrees plus 20 degrees plus 100 degrees plus angle 4. So 360 is equal to 220 plus the measure of angle 4. So since we are after the measure of angle 4, we now have angle 4 equal to 360 minus 220. So that gives us 140 degrees. Therefore, the measures of angle K and angle 4 are 100 degrees and 140 degrees respectively. We have reached the end of our discussion. I will be leaving you with exercises to test how much you've learned and how much this video has helped you. I hope you enjoyed learning. This is Teacher Daryl signing out.